Hey there, Russ here. Welcome back to the shop. Okay, now you did it again. You gave me another excuse to do a rambling. So let's talk about batteries, battery-operated tools, and today we're also going to touch on the subject of battery chargers. I didn't want to mislead anybody. If you haven't noticed, in all of my battery charging projects, like my Ryobi power outlet box, it only draws the power off that battery. I do not charge that battery from that power outlet. When it comes to especially the tool batteries, I buy only Ryobi batteries. I only have Ryobi smart battery chargers. I don't even use my old Nikon charger to charge lithium batteries, what they have now for batteries. You want to use a recommended charger to charge any battery based on what the manufacturer says you should do. I understand enough about batteries and lithium technology and that sort of thing to, if I wanted to build my own charger, I could. But when it comes to chargers and the batteries, especially tool batteries, let's stick with just tool batteries. When you start talking about other aftermarket batteries, like my battery pack that I'm working on, the battery power station I'm working on now, where I'm using two 16 amp hour batteries. Those are 12 volt batteries, generic batteries. They are not a specific tool battery. For that, when I put to do the charging on that, I made sure that those batteries were compatible with the charger that I used. It was designed to charge and discharge those batteries properly. So charging up a battery is a total different thing, especially on lithium batteries for power tools, because most of these tools now today, that's what they're using is lithium ion cells, lithium iron phosphate cells. That's what they're using. And they inherently have certain characteristics. That is why you can take tool batteries from one battery manufacturer, and as long as the voltage range is the same, you can use it in another tool, theoretically. In fact, if you wanted to, you could go out and buy an aftermarket cells and build your own battery, as long as it meets that range of, there's several factors involved with how they design their batteries. And part of what you want to be careful of is that you want to use their charging methodology to recharge their batteries, to keep their batteries to last as long as they should without you putting them under undue stress to shorten their lives or to actually damage them. Most of these manufacturers, these tool manufacturers, they're all using the same technology and the same, mostly they're using the same number of cells and everything. It's hard to explain how they all work, but really the difference is that today's power tools mostly run on that 20 volt, 18 to 20 volt range. And what that means is that any battery, if you understand how batteries are made and the cells in them, each cell has a certain nominal voltage and actually has its own range. And when you add them all up, they add up to a specific number of volts that they want to have available for their electric motor that they are using in their tool. Now, all of these tools are using pretty much the same technology and the same voltage range for their tools. An 18 volt tool is really a 20 volt tool. And so they use different terms. And so you can change the battery. It's all DC current. And so the tool at this point doesn't know what kind of battery is actually using. I could hook up if I wanted to, I could hook up a 12 volt car battery, use a step up booster, a buck converter that steps up instead of down to 18 volts, and I could run the tool off of a lead acid battery. It doesn't care where that power comes from. All it really cares about to run is it needs DC volts within a certain range. And most of those run from like 16 volts up to 20 volts, 20 point something. So it's a technology, and they all kind of copied each other on it. That's why the batteries kind of interchange. The only difference between most of these batteries, especially at first, was how they fit into the tool. This one, the Ryobi, is famous because it has this long neck. And we'll get into more about this design thing versus the sliding one, and advantages and disadvantages of both ways. But it doesn't matter, because when you cut across these two here, the positive and the negative, that's what's tapping into that tool, is on those two terminals. This terminal here, it does have uses, but they're more technical and they have to do with some other things, especially, and this one down here too. That has more to do with charging this thing up than anything. So, and temperature checking while it's charging, because while you're charging it, this thing is vulnerable to overheating. And therefore, that's why you want to make sure that you charge these up to the exact voltage that they want it to be charged up to get full saturation, and they don't want it to go below a certain voltage. That's why they pretty much have a BMS in all of these things that run, so that, because this has several cells in it, and those cells have to all be pretty much the same voltage at all times. If one of them, like a 3.2 is the average voltage of, let's say, a cell. If one cell is at 3.2, another one has got a problem, and it's only generating 2 volts, that puts a load on your battery pack that that one battery is dragging everything down. You could go in, replace that one cell, and everything be back up to normal. So that system is in here, and it controls how much power you can put into it. But it's the battery management that watches those little batteries, and each one of them is actually being charged up to that 3.2 volt level. And when all of, let's say there's 6 of them in here. If there are 6 of them in here, 5 of them, if of those 5, one of them is a lot higher up than the others. Most of them hit 3.0 volts, and one of them hits 3.2 volts. What happens is that BMS shuts off all power being put into it. Won't let you put any more than that, because that one hit the maximum cell saturation, of voltage saturation of that cell. So when these batteries are being charged up, those are very important that they stay even to each other. And that's why when they talk about when you build your own battery, you really got to make sure that your batteries are balanced. And that's what's most important about these. But drawing it off, the only thing you have to worry about, because it draws off of all cells at the same level. Whatever they can put out, they put out pretty much the same amount, because they're the same amount of voltage at all times. If that gets out of balance, that's when one of these things starts messing up. So if you watch a couple of battery repair, it doesn't have to be the Ryobi battery. You can look at look at a couple of different ones of how they repair these batteries, these tool batteries, and you'll see a similarity between them. And you'll see differences, but you'll see similarity. But as far as the electronics, the only thing they're doing right now on all these tools that I have seen, and correct me if I'm wrong, and I know there are also exceptions, but as a general rule, they only are using the positive and the negative posts, and they're pulling the voltage right straight off this battery is all they want to do. And the tool itself is taking that voltage and using it. And the battery tells it when it's not going to give any more voltage to it, and then it shuts off. That's the only thing the battery really does. So it doesn't matter whether this is a Makita 18 volt or a DeWalt 20 volt or whatever they are. They really are all the same, believe it or not. Inside, it's still DC volts, and they still run in that 18 to 20 volt range from when they reach their highest saturation point to when they reach their lowest saturation point. They're pretty much all the same, so each one will run each other. As I told Mark, that in all reality, if you had 2 drills, one 12 and one 18 volt, I could put an 18 volt battery in there, DC, and run it. Now, it probably sound like it's running on steroids, or it might actually burn it up the first time you hit the trigger. It depends on how it's wired inside that tool. You could damage the tool because you're pumping 18 volts into a motor that's been designed to take about 12 or 13 volts maximum. When you go over that, bad things can happen. One of the things that happen as you increase the voltage, you get more horsepower out of that motor, but it can only take so much, and then it's going to blow up. So the battery ranges on all the tools out there right now is in that same range, and that's why you can interchange those batteries if you want to. Now, manufacturers are figuring out that you're doing that, and they don't like it. I'm sure they probably will come up with a way to have these batteries communicate with the tool so that if he says, you're not speaking my language, I'm not talking to you anymore. So you can't put a floppy disk from a Apple into a PC and expect it to talk to and communicate whatever it has there and run a program from it, because they're different. Same thing with batteries. Eventually, they're going to have them talk to each other, so you won't be able to do that maybe. But right now, all they do is the only way they keep them proprietary is the fit. They all are pretty close to being the same thing. Now, that's not to say that, then I had people say batteries that are, somebody in particular told me, he says, his Makita batteries last twice as long as his Ryobi batteries. And all I can say is that I don't know for sure the range of different batteries. These are both, one's a generic, but these are both batteries that fit the Ryobi tool. But if you look at them, this one's a lot bigger than this one. This is a 5 amp hour. This is a 1.5 or a 2 amp hour, something like that. They're both 18 volts. I can plug either one in there, and two things happen. First and foremost, this one will last a lot longer. But actually, sometimes, because it holds its voltage, because there's more of them here, it'll hold it higher. This battery will feel like it's ready to quit like on a circular saw more than this one. Seems to have more horsepower than this one. It definitely lasts a lot longer than this one does in the circular saw. So you can get a difference in span, but that isn't because of the difference in brand in the batteries, because they are still using the same cell technology in all their batteries at this point. So usually when they last longer, it's because they have a bigger amp hour, which means how many batteries are in here, or how strong are the batteries in here. Are they 1 amp hour batteries, or are they 10 amp hour batteries, or cells, I mean. And if you've got all 10 amp hour cells, you're going to get a lot more power out of this, and you will. And by power, I mean longevity of use. The amount of power is still going to be at the 18 volts or 20 volts, whatever it is. So you can interchange batteries on tools now without it being a major problem. Will that always be the case? Who knows? The market's always changing. But if your question is, am I going to damage it? I doubt it. But if you look out there, there's lots of people out there that have already been doing these things. So, but when it comes to charging them, that's a total different ballgame. When it comes to charging lithium iron phosphate batteries, which is what these are, they have a certain inherent characteristics that you have to follow. I can't take if I made a Ryobi battery out of a lead acid battery, yes, that would be impractical. It would be a little larger. But I could do it, plug it into the tool and use it. But it would actually have different characteristics as to how long it would last and all that. So, and I would definitely have to charge that differently than I would my lithium iron phosphate type. So, charging them is okay, but I recommend to always use the manufacturer's chargers to charge these up. And that's why I said that when I made my power outlet, you don't charge these batteries up in that. All you do is pull power from it. That's all it's designed to do. When I'm ready to charge these up, I put them in my power station, charging station that I built, which is basically 4 individual chargers that charge Ryobi batteries like this. And it takes care of charging all my Ryobi batteries. I don't think that I really would want to myself. Could I build my own charger? Yeah, I could. I'm pretty sure I could do it. But I don't think I need to reinvent the wheel there. The only thing I'm doing is taking advantage of some of the advantages of the Ryobi and other tools. And that's where the adapter comes in. So let's talk about this adapter for just a second. Somebody mentioned about contractors using adapters. Well, first let's talk about real quick about the adapters. The Ryobi is inherent. You can spot them a mile off because they have this stem. And that's a Ryobi battery. Most of the others have a slide in. They don't have this stem at all. You have your contact points on the sides. And that's okay too. That's not a problem. But they adapt different. So if you want to adapt one of these to a DeWalt tool, guess what? Your adapter has to fit this ugly stem. Whereas if you're trying to fit a DeWalt battery, which slides in, that's going to have a lot less room needed for that adapter in order to have that battery hang under there. This thing is going, because of this long stem, this thing is going to set, if I put it in here, then the battery is actually exposed from here to here, and the center of balance is balanced from the factory. But if this was a different brand, there is not that opening there to stick this in. So that thing that would stick down like this, making contact to that adapter, that makes this thing hang lower. So going from a Ryobi battery to a Makita tool or something like that, you may throw this thing off balance. And that's why that's one of the reasons why if I was a contractor that used that tool constantly all day, I wouldn't want to use a adapter and use a different battery just to save money. Because that tool means more important to me to work properly and not have any problems. And that adapter potentially is another link of something going wrong, if you think about it. Because you've added complexity to the union of these two pieces by putting an adapter in and using a different battery. In a small shop like this, it probably isn't a big deal. But what brought this whole thing up was the idea that I told you that I have a one tool, which means one battery type in my shop, and everything is based on the Ryobi battery and the Ryobi tools. And it was mentioned to me, so yesterday I talked about having one battery system. If I wanted to, I could start buying Milwaukee. In fact, I thought about maybe doing that, buying another tool, buying an adapter, and see how these batteries do work in there and how clumsy it is it dependable. But I have had a couple of comments about it. And you're probably right. The contractors would look at that and say, no, thank you. I don't want an adapter. I'll just buy the battery made for it. It's simpler, easier. Plug it into the charger it's made. I'll keep all those chargers around. And I can understand that too, and I would agree with it. But in your own little shop, especially if you're starting off, and especially if you've already made the mistake of buying a couple tools that you really like, and now you have to have two different types of battery chargers there to charge up to two kinds of batteries. That gets to be when the complexity of that, as opposed to one tool brand, one shop, it does add complexity. And that's what the point I was trying to make. So you could have just a one battery shop, and every time you buy a tool, buy the adapter for it so that you can use that one battery type that you would want to use. So adapters can possibly work in your scheme of things, or if you've already bought a tool that you just don't want to fight with, but you really want to go to one particular brand, but that particular tool is a different brand, I ain't giving that tool up. Well, probably the adapter is a good example of where maybe you can do that so that you can stick to one brand battery. The key to this whole thing really is that it's the battery consistency. I have only one battery that I use, so I have only one style charger. And if I need just any of my tools to work, I can grab any battery there that I want and use it because they're all the same. And when you start having Makita and DeWalt, then you have to start thinking about those things. It just makes it more complicated. And sometimes some people would rather have the right tool and the right brand of tool so they don't mind that complexity of different batteries. But in a shop, if you really want that complexity of tools where you can buy any brand because it's your favorite tool in that brand and only that tool, and another tool might be a better brand, another brand is better, so you have all these different brands, you could theoretically still be a one battery shop, have only one type of battery, and then put up all the chargers you need to keep up with however many batteries you keep in your shop and keep them all the same. That would make it easier to shift your batteries in and out of your power tools. So, yes, you can use one battery in almost all the tools out there. Now, before you commit to saying, I'm going to use Ryobi batteries and I really want to buy the Milwaukee tool, you might want to make sure you do some homework and make sure that the 18 volts, that the volt range of what that tool uses is compatible to what the tool range of what the Ryobi battery is. Because some tools might run on 36 volts instead of 18. In which case, you can't plug one of these in to run a 36 volt or a 40 volt tool. Even with an adapter. You actually technically, and I don't mean to do this, it's going to confuse everybody. You could use two 18-volt batteries in place of one 40-volt battery. And I know that's going to probably explode some minds out there to know that, but it's true. Serenity Sue, I think was the name of it. I talked about them in the past. He's made several different things and some really good stuff using the Ryobi battery, but he also has 40 volts and some 18 volts. And one of the things that he did is he took two 18 volts, made an adapter for them, so he could take two 18 volts and plug it into his 40 volt lawnmower that ran on one 40 volt Ryobi battery instead of the 18 volt style. Now, my lawnmower runs on two of these. I suspect that probably those two lawnmowers aren't too far off from each other in technology inside, that the only difference is they committed to making this one so that I could still use my 18 volt batteries rather than having to go out and buy 40 volt batteries. So even if you wanted to buy a 40 volt tool, but you really didn't want to get into doing 40 volt batteries, there's a good possibility that if you find the adapter or make the adapter through a 3D printer, you could make an adapter so you could plug two 18 volt batteries into probably most 40 volt tools out there that are out there, or apparatuses, whatever you want to call them, units. Because the 40 volt battery is kind of getting noticed out there, but actually the technology in that thing is not and much different than the technology in an 18 volt. It's just more cells. So if I put two of these together, it happens to come out, from what I understand, what the 40 volt system is. And I think that's all it is just two 18 volt battery systems put together into one 40 volt. So correct me if you're wrong. I may be not exactly right on that, but I think I'm pretty close. And I think Serenity Sue kind of proved that when he took two of these and made an adapter on his 3D printer so he could plug two of these into his 40 volt lawnmower, and it works fine. So don't be surprised, and it is confusing, but that's why I like the idea of just picking one brand battery, go with the 18 volt system right now, and even if you see something at 40 volt you want and you're in the one brand battery thing still, there may be a way that you can still buy that tool and just use two 18 volt batteries instead of a 40. Now, if that doesn't make your mind explode, then you're doing pretty good today. Because all these things are kind of new, and they're a little more complex than what I said. But basically, 18 volt batteries are all really pretty much the same technology, and they do work within the same voltage range. So you should be able to take one of these and plug it into another battery, because they're not talking to each other yet. It's just checking for 18 volts coming out of this thing, and as long as it's got the volts that it wants, it'll run off of any 18 volt of battery that you have, whether it's 3 6-volt batteries, lead acid batteries, or anything in between. You just never know. It doesn't know the difference. So I've been blowharding here a lot, but I have a couple more things I want to tell you. How do you find adapters? Etsy, you might be able to find some on. eBay is probably your best chance to finding battery adapters. Now keep in mind, do you want a battery adapter that fits one battery and fits different tools? Or do you want one tool adapter that fits other batteries? I don't know how you want to do it. Make sure you keep that unconfused, because when you start buying battery adapters, you want to buy something that's backwards. So... but it's not hard. You can find them out there. That's the two places I know of. Probably the best place is find yourself a good friend that has a 3D printer, or go out and buy your own 3D printer and start doing them yourself. It isn't that difficult to learn to do it. I don't want to do it. That's why I choose not to. Could I do it? Of course I could. I used to be a programmer in computers for years. So, but I choose not to use that technology in my workshop. That's another story for another time. So, the 3D printer really is probably your best solution. If you're going to go and start buying other tools, it'd probably be nice if you just build what you need as you go along. It'd be best. So, you want to take a look at that, do some research. And if you're going to make adapters to fit Ryobi batteries, you may need to buy some other small pieces of hardware so they fit into your 3D printed plastic piece when you get done. So It's not going to be just, boom, easy to do. You probably have to do a little work, or if you go out and buy them, you're going to spend a little bit of money for them. So in other words, instead of this drill costing you $50, you got to spend another $16 for an adapter for it. So now you really got $66 wrapped up there. Is that still worth the price to go to that brand instead of sticking with the battery brand that you have? That's up to you to decide. It's your shop, whatever way you want to do it. But it is possible to do those things. I like simplicity of the one tool. And if Ryobi doesn't make it right now, I just kind of go, nah, I don't really need it. And I try to stick to what Ryobi is making for my battery-powered stuff that I buy as a general rule. But it is an option. Okay. I thought it was an interesting comment, but I really kind of thought about it for a second. One comment was made to me about, he says that he wants to do away with all his battery tools. He's in his shop only. He just wants plug-in tools. And you know, it's funny because there was a time when I moved from doing handyman work, working for a living, to where I was only in my shop. I was never out. And I thought about that, and I thought, that is a good idea. I think I'll just get rid of all my battery tools. But it didn't take me long to realize that even in the shop, I actually like the battery-powered tool over the plug-in tool when I'm using them around the shop. So, yeah, you can do away with them if you're going to be in one location, all corded tools. But I'm not so sure that battery-operated tools aren't getting to be a better price than 110 plug-in tools. So, you can, like I said, you can use that, you can do away with them, but I think maybe I kind of decided, nah, I think I'm going to keep mine around. I actually like my battery-operated tools. But he also made one other comment that never dawned on me, and that is that he talked about using 110, and I got to thinking, you know, there's a lot of stuff out there that runs on 110 that actually is running on DC current instead. All that happens is those wall warts you see, all that's doing is going from 110 voltage AC and moving it down to a DC current of a lower voltage, probably 24 volts or less. And it could be anywhere in that range. So if that tool runs on, let's say you have a tool that plug in, and if you open it up and you see that, or it has that wall wart, measure what's coming out of that wall wart, or look at the wall wart and it'll tell you what the output is. You may be able to do away with that and just plug in your Ryobi battery where the wall wart was, throw all that away and plug that into a battery and use a battery operate a plug-in tool if it's a DC motor. So there's a lot of things that run on DC current that you don't even realize that's what it's actually doing. You think it's an AC current product, but it's not even. So DC AC current is the two technologies that we use mostly. Well, there is a third, air power. And nailers are a good example of that. And somebody mentioned that too. And when it comes to my nailers, I almost never use my air tools anymore. I have a lot of brad nailers and different nailers that I use the air power for. But ever since I bought my tool that was the brad nailer, that's all I ever use now. I don't even turn my air power on. When I want to blow something, I usually just use my shop vac, switch the hose to the outlet side, and I blow away using that. That's more than adequate. So I don't even find myself turning the air power on much anymore, which I love because I think I bought the noisiest air compressor that you could buy out there. I swear, that thing is horrible. So anyway, power tools and air tools, if you think about it, if you can get something in a DC power tool instead of air power, that's not bad either. And this one guy that was going to corded tools, he did mention to me that he wanted to do away with them all, but he couldn't understand. He can't find an impact driver on 110 voltage. And I thought, well, that's kind of weird, isn't it? I never thought about that. But at the same time, that's why I haven't given up my brad nailers completely, because I really wish they made Ryobi made a pin brad nailer. I love my pin brad nailer, but the only way I can use my pin nailer is with the air compressor. So what's happening right now? I probably rarely use my pin nailer when I really wish I could be using it because I haven't turned the compressor on. So I wish they would make a battery-operated pin nail if they make anything. Anyway, those are some of my thoughts for this. If you pick a brand that you want, you don't know what brand to go with, that I can't answer. I would prefer to buy a brand that most of the tools I look at, that's what I would like to have, that brand tool. Or I would be happy with that brand tool. That's why I went with Ryobi. Is it the best out there? No. But I've not yet had a tool that I've been really disappointed in from Ryobi, with the exception of their supercharger. Another video. I don't want to talk about it. But other than that, I have been very pleased and amazed at all the different things that you can buy so you can operate your Ryobi batteries. In fact, like I said, around the house, my weed whacker, my lawnmower, they all run off of my Ryobi batteries too. So it's a great solution for people that, even if you don't have much of a shop, you just barely want to fix things once in a while in your garage, this battery system is still a good one to go with the Ryobi tools, because it has such a wide variety that other things that you might use to be able to use your battery power tools around the house. So yeah, these are all food for thought. Let's see if I have any more here. No power tools. I'm charging batteries. Impact driver. What about battery? So I think that's about everything that I talk about. But one most important thing, I'm going to go back and say one more time before I end this. This battery right here, it's a Ryobi battery, and I use nothing but Ryobi chargers. If you're going to charge lithium-ion battery, don't try to cross over from one brand to another to charge them or build your own. You can do it if you want, and like I said, I could do it, but you better know what you're doing if you're going to do something along those lines. It's not as complicated as you think. And I would suspect that most lithium battery chargers, whether it's one tool or another, I suspect that if you had the wiring and the adapter to plug it in, you could probably plug one of these into a DeWalt charger, because the battery range is pretty much the same on all of them anyway. And you should be able to do that theoretically. But it's not worth the hassle, because if you're going to keep just Ryobi batteries around here, then buy only Ryobi chargers. As you need more and more batteries, you'll buy more and more chargers, but at least it'll all be the same one, so everything plugs into all the same 4 chargers. So I have like 12 batteries or 10 batteries or whatever it is around here, but I only have 4 chargers that I use for all of these batteries, and I probably could get by with 3. Be honest about it, and maybe even 2, but 3 would probably be the ideal around here. But I have 4, and it's nice to have. So that's, I think, a better way to go. If you're going to dedicate to one battery, make sure your charging systems are compatible. Don't try to adapt your chargers to fit other batteries. It's not worth the hassle or the challenge of it. So I hope that made that all clear. I still think that it's a good idea to go one battery tool, one brand tool in the shop, but you could go to the one battery shop instead and buy all these tools if you want. But you're going to have some new things you have to watch for and understand, and make sure that things will work together. So, any thoughts about any of this? Any ideas? How you would do it different, or how you do it different? Or if you have any questions and want to take this again, be careful about those questions, though, because that could lead to another rambling. You know how that happens, and today's proof of that. So, just leave your messages and leave your comments down below and your thoughts. I enjoy reading them, and like I said, that's where a lot of my videos come from, is what you guys are talking to me about, and it makes me start thinking and try to explain. Hopefully I've made everything more clear today about the do's and the don'ts of the one battery shop. So, questions, comments, leave them down below. If you like this video or you learned something here, hit that like button. Lets me know I'm doing the right thing. And if you're still here, because this is a pretty long video apparently, I just want to thank you and tell you that I'm nowhere near done. So please come back again. We'll see you guys again soon.